Morning. Alright, we just finished 7.4 on Friday, and today we're starting complex fractions. But just a reminder that complex fractions are nothing but reapplication of one operation we have already covered, which is division. So complex fractions is actually division in a different setup. Okay, so why don't we go over and see what we did on Friday again. On Friday we finished a few questions about how to find addition and subtraction of fractions, and they were challenging because we need to be able to perform addition and division, addition and subtraction. We need to have common denominators. We didn't have such requirements for multiplication and division, so it was challenging. Now, what's new in 7.5? I said we're going to do divisions. However, these divisions will involve additions or subtractions on the top or bottom. So these are really complex divisions. So that's why they call it complex fractions. It's not simple fractions we have done before. It looks like I need to rerun this. Again, on Friday, the last thing we did was problem number 14. It's addition and subtraction of fractions. And before addition and subtraction of fractions, we have investigated division of them, right? We divided two fractions, but the regular symbol for division is this. Sometimes I said that division may appear with a fraction bar. This means also division. So all you need to do is convert this problem into regular division symbol with top on the left and bottom on the right. That's it. So this is still simple division. Why is it really simple? Because there is no additions or subtractions on the top and bottom. Look at top. It's just a fraction with products on the top and bottom of both fractions. No plus or minus symbol. Again, plus and minus symbol between fractions is our nightmare. Today's class, we're going to have this same symbol, long fraction bar. However, the problem right now is on top or bottom of these expressions, you have something nasty. You have additions and subtractions. You see? Addition, subtraction together on the top. Only addition on the bottom. How do we handle these questions? Okay? Don't worry, it's not that bad, but why don't we first recall how we did it with simple top and bottom. So this is simple. This is simple. Why? There is no add or subtract symbol. All we need to do is take 5 over 24s, create a division symbol, put 7 over 8 afterwards. Once you see the division symbol, so you put the top to the right, left, bottom to the right. After the division symbol, how do we do the division? I forgot. Yeah, we turn this into multiplication. Don't do nothing to the first part. Okay? But the second one pays the fee. We flip the second one. In other words, we take the reciprocal. This is the technical word we use for the flip. We take the reciprocal of the second one. Correct? And we multiply across. Is that all? Is that so? No. We first factor things as much as possible. I can't factor 5, but I can factor 24 as 3 and 8 s. Why do I break it into 3 and 8 only, not 3 and 2, 2, 2? I think 8 can be broken into triple 2, right? Why don't we go all the way? Because I foresee something. I see something coming. What is it? Because I see 8 already here. I feel if I stop at 8 here, don't break further, these will cancel. But is it wrong if I break this further? No. You just need to break this one as well. If you break this guy, you need to break this one as well so that they can cancel. 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 Okay? So you break, either break all the way to the final result, or if you see something matching already, you don't want to break numbers into the simplest factors at all. Okay? Now I can't break 7, 5, and 3, so that's it. This is 1. 5 times 1 is 5, and 3s and 7 makes 3s and 7 makes altogether what? 21s. Okay? This is our final result. Alright. From now on, I'm going to skip this part. And I will go directly to this line. Is it okay? So from now on, when I see a simple single fraction, I'm going to call this, instead of a simple, single fraction, a single fraction on the bottom, all I'm going to do is I will take the top one to the left, right one to the right. Once I flip, then I take it here. Okay? Flip and put it to the right as a product. Can we go directly from this stage to this stage? Do we have to show this middle word? No. Again, this is skippable. You can skip it, then go directly top times reciprocal of the bottom. This is reciprocal of bottom. If again you have only one single fraction on the top, single fraction on the bottom. Extremely important. Okay? So to be able to perform complex fractions, this is the key word. Get single fractions on the top and bottom. No matter what you do, get something, one fraction on the top and bottom. Then we flip and multiply. Flip, multiply, flip, multiply. That's it. Are we ready for our first question? No, second question. How many fractions do you see on the top? Keyword again. How many fractions? First, where is our main fraction bar? This is our main bar. Let's make it really long so it's visible. This is our main. Here is top. And here is the bottom one. How many fractions do you see on the top? How many? Come on. How many division bars do you have on the top? Just one. Look, just one. Yeah, it's messy fraction, but it is one only. How about the bottom? How many? One. So this question is still considered easy type. This is still back to 7.3 simple division question. Why? Because you have only one fraction on the top, one fraction on the bottom. So you can go immediately to the second stage, turn this into multiplication of top, and bottom. Right? Correct? Everybody agree? What's wrong?
Bottom.
Yeah, I need to flip the bottom. This hasn't been flipped. This is the common mistake happens. You just copy top and bottom and multiply. No, this is not a multiplication question. It's division. So somebody needs to be changed to make it multiplication, which is the bottom one should be flipped. 10a minus 45 goes top. 3a goes bottom. Okay? Alright, next, shall we multiply across? No. In a multiplication question, first step is always factor. So we need to break a square, not necessarily, but if you insist, you can break it as double A. You don't have to. Can you break 2a minus 9? Can you factor this? 2a minus 9. Any common terms? This is a binomial. Binomials usually, unless they are square or cubes, if they are only single powered, then you just look for something common among terms. 2a 9. Do you have anything common? No. They're not breakable. How about 10a minus 45? Yep. 10a minus 45. 10 has factors 2 and 5. 45 has factors 9 and 5. Actually 9 is 3 and 3. You can break as 3 and 3, but I won't, because it's not common. 3 is not common in the first one, only 5s. So you can factor 5 out, and it's 2a minus 9 left. So 5 out, 2a minus 9 stays. And we have 3, which is not factorable, and a, you can't factor it either. Okay? Alright? Now, anything matching on the top and bottom so we can cross out. 2a minus 9. Look. Anything else?
Could you actually cancel a because it is multiplication?
Yep, we can. More? Anything more? Nope, we're out. We're done. So circle the ones left out. This is 1 only, and 3. So 8 times 5, 5a. 1 times 3, 3. 5a over 3. Any questions? What was the answer for this one? 5 over 21 S, and this one is 5a over 3. Okay, it looks like this section is so easy. Why should I even put only 5? I should have put more. No, challenging ones are starting. So what's the main difference on this question compared to the first two? Where is the challenge? What makes the challenge? Yeah, multiple fractions, and unfortunately among them is an addition and subtraction. This question is not ready yet. It's not ready for flip and multiply process. Not ready. So how do you get ready? You need to separate top and bottom and get them into one single fraction. Top and bottom. I literally, some people wants to work them on place right here. They can do it. They are really fast. fine, I'm okay with that. But for beginners, please, I want you to literally separate top to the left and bottom to the right, and combine those fractions into a single fraction. Look, there are two fractions here, 8/9 and 1/2 on the top. Take it here and combine it on the left. And on the bottom you have two fractions. I want you to combine this on here and go back. Once you combine them into single fraction, single and single fraction, go put them back into the expression and flip and multiply that. You're free to flip and multiply once you get single on the top, single on the bottom. Alright, question is, how do I combine this into one fraction? Oh, this is a subtraction. I will just subtract 8 minus 1 and 9 minus 2, right? 9 take away 2, 8 take away 1, 7/7, which is 1. Cancels, right? Am I right? Is this how we add subtract fractions last time? Now, what do we need to get first? Common denominators. We need to get common denominators but first we need to break those denominators into simplest factors, like 9 is 3 and 3, 2 is 2. You need to take a colored pen and see what's matching. Anything matching so we can shade them? No, nothing is matching. That means everything is distinct, different. We need to put all those terms missing in the second one next to top and bottom, and everything missing in the first one, put it in the top and bottom and make them matching. So what is in number 2 fraction, which is not in number 1? The term 2. So I put term 2 here. And I have 3 and 3 present in the first one, missing in the second. So I put 3 and 3 into this one. Since there is no match, you could keep 3 as 9. I broke 9 into 3 and 3 for the sake of maybe there's something matching, I can overlap them. But they didn't match. You can keep this as 9 if you wish, but it's no harm if you break it into 3 and 3. That's fine. 8 times 2 is 16. 9 times 2 is 18. 1 times 3 times 3 is 9. 2 times 3 times 3 is 18. Look, they matched. What basically we did is we brought this denominator and multiplied the first one with the second denominator, and you take second term and multiply the first denominator with the second, 9. That's what we did actually, right here. Because nothing was matching, no common pieces in the denominators. Now, since these are the same denominator, we can combine them, and 16 and minus 9 subtract. We get 7/18 in the top fraction. Top is single now. You see? Single fraction. Good. Top is ready. Now bottom side. For the bottom side, I see something matching already. 12 is 2 times 4 times 2. No, it's not 2 times 4 times 2. It's 2 times 2 times 3. So I already have these guys matching. Match. So you don't have to try to match them. What's not matching is 2 and 3 in the second fraction. So I need to make the first fraction getting 2 and 3 by multiplying top and bottom with that. 2 and 3 coming in here. This one doesn't need anything because there is nothing extra in the first one which is absent in the second one. There is nothing absent. Second fraction has something more. Or in other words, what we need is, this thing is 6. We are multiplying both sides of the first one is by 6 to make them matching. 12, 12. That's what we are doing. But I'm just applying the same principles from Friday. Break, color the matching terms. Unmatching terms are going into the other denominators, okay? Both sides though. 5 times 6 is 30 over 12. This is 2 times 3 is 12. And this one is still 1 over 12. 2, 3 is 12. And the total is 30 plus 1 over 12. That is 31 over 12. That's a single expression on the top as well, bottom as well. So what we do is, next is we combine top and bottom back again. 7 over 18 goes here, and this guy goes there. Question is now ready. Ready for what? Ready to multiplying reciprocal. Flip the bottom and multiply with the top. So again, top doesn't change. 7 over 18. We turn the division into multiplication with reciprocal of the bottom. 12 over 31. Okay? Shall we just multiply across? No, never. Don't rush to multiply. First break things and cancel. Can you break 7? Nope. 18. 18 is 3 and 6. But I think we can break 6 again as 2 and 3, right? I just want to break all the way. But 3 and 6 are fine as well. 12 is 2, 3, 2, right? 6 and 2. I broke 6 into 2, 3, 4. Oh, I shouldn't have broken 6's actually. They would cancel. It's too late. I did it already. That's fine. 31. Can you break 31? Big number, but it's weird. I can't break it, right? Can you? Can you find two numbers multiplying into 31?
31 and 1.
They don't count. It should be a pair different than 31 itself and different than 1. Any other than 31 and 1? No. So we call this number prime. It's not breakable. Where is my mistake? Somewhere mistake? No. Is it a mistake? Good. So let's see what's matching and canceling. These are canceling. And what's left is here 7, 2, 3, 31. So we multiply them across. 7 times 2 is 14. 3 times 31 is 93. Good. Any questions? Okay, here is a review of the steps. I see top and bottom is not ready for division because I have multiple fractions on top and bottom. So I separate them, compute those multiple fractions, combine them into one, and I reunite them, bring them back, and flip and multiply the top bottom. That's it. When I'm multiplying, of course, we do the routine procedure. Factor, cancel, then multiply. Any questions? Alright, 2 questions left, but they are getting worse. Alright, I'll give you a couple minutes to think about this on your own. It's not much different than the previous one, except it's not addition or subtraction of fractions, it's addition of a whole number with a fraction, and that fraction doesn't have only numbers. On the bottom you have a variable. Let's see what kind of a difference does it make. Alright, you have 2 minutes. Alright, let's see how we do this. I separate top and bottom again. Top is 5 plus 5 over x. Bottom is 1 plus 1 over x. They are very similar. Whatever tricks I'm doing on the left, probably I'll be doing the same trick. So we're kind of doing double work. Now, problem here is, comparing to previous question, These were already fractions. I knew how to add them or subtract them. This is not a fraction. How can I combine and make one single fraction here? This is a single fraction plus a number, which is not good. We need to get only one single fraction. Single fraction, nothing else. So how can I add these two? Is it 5 plus 5, 10 over x? No. Yeah. Although it looks like a whole number here, it's actually easy to make a fraction there by putting 1 under. And we need to just match denominators now. 1 and x already been factored. All you need here is you need to bring an x to this one to match them. 1x, 1 times x is x. So we get here x common denominators now. 5x plus 5. Okay? Same deal on this side. This is 1. I need to multiply both sides by x so we can have a match. 1 times x is x plus 1 over the common denominator. This is x, so they already have a common denominator. I combine them, so it's x plus 1 over x. Now what we need to do is, this is single fraction now. Look, I see nothing but a single fraction on the top and bottom. I will bring them together. I will bring them together in the expression, original expression here. So make that big division symbol and put the top to the top, the new top to the top, and the new bottom to the bottom. And do what with these? Change this quickly into product with reciprocal of the bottom. Okay? Look, these are already canceling. X and x. How about these two? Is the result 5x plus 5 over x plus 1? No. 5x plus 5 can be factored as 5 times x plus 1. This is already x plus 1 as a block, and they do cancel. So the result is only 5, nothing, nothing, nothing. 5 times 1, 1 times 1 is just 5 over 1, which is just 5. Okay? This question wasn't actually that bad, right? Okay, the next question. Two minutes. Any different answers? Different answers. You can fix it. Alright, last call. Just 7 over 2. Okay.
Six or five.
6 over 5. Wow, 3 different answers so far. Any more? Alright, let's do this together. What is the top one? 7 over c plus 1. I can see what kind of mistakes you've done. The second one is not a fraction. To combine a fraction and a whole number, you turn the whole number into fraction first. Put 1 under. Oh, I see. These are already matching. Match, match. All we need to get is c on this side. So I'm going to add a c to both sides. Right? I'm going to add to the c to the top and bottom. Is that right? To make the c plus 1, c plus 1 matching. Am I right?
Be C plus
1.
To be times C plus 1.
Yes, this is incorrect. We do not have the tool to add both sides. This is ridiculous. Wrong. Don't do this. Oh, just because these are already ones matching? No, they're not matching actually. This is a block. This is a block factor here. You either match the entire c plus 1 with 1 or they don't match at all. So these are not matching. So to make these matching, this is already 1. You need to put c plus 1 to both sides of the right side. And 1 times c plus 1 is going to make c plus 1 and they are going to match. But we need to multiply this side by 1 so you can get this 1 here. Not necessary. This is redundant. It's not necessary because 1 times anything is that thing. Okay? 1 times 7. So multiplying by 1 doesn't change anything. This is optional. You don't have to do. Redundant actually. So 7 over c plus 1 is the left side. The right side is 5 times c plus 1. And 1 times c plus 1 is c plus 1. Am I right? Another mistake happened. Yes. 5 times c plus 1 is 5c plus 5. Now let's add these together. 7 plus 5c plus 5c plus 1, which brings us 5c plus 12 over c plus 1. Look, 7 and 5 are like, so I add them as 12, and 5c is 5c. So this is the top. This is what this top is. I'm done with the top. Oh, can I factor this numerator 5c plus 12 and cancel with c plus 1? Can you factor this? No, there is nothing common between 5 and 12. Let's do the bottom now. It's the same work. Nothing different. Slightly changed numbers, but I will repeat same procedure. Multiply both sides by c plus 1 as in I did here. Get c plus 1. The first one doesn't change. The second one is 5c plus 5. Add the tops. No. 2 plus 5c plus 5 over c plus 1. Just copy one of the denominators. That is 5c plus 7 over c plus 1. This is the bottom. I combine top and bottom now. Combine top and bottom. 5c plus 12 over c plus 1 is what you have on the top. Bottom is 5c plus 7 over c plus 1. Flip and multiply. Flip and multiply. Now what is matching here? Look at this. Aren't these matching? C plus 1, C plus 1. They as a block cancel. Question is, can I? No, this is 7, right? I miscopied this one. This is 7. Can I cancel these two 5 and C's? 5 C's. Can I? No. These must match as a block, but they are not matching. 5c plus 7, 5c plus 7. You cannot cancel them individually. So they won't cancel at all. Take it back. These are your results. These two will survive. 1, 1. 5c plus 12 times 1 is 5c plus 12. And 5c plus 7 times 1 is 5c plus 7. Okay. Unfortunately, nobody could get the right answer.
I tried to fix mine. I got something that's none of the answers. So.
Still didn't get the right answer?
I mean, I got C plus 8 over C plus 3 after I fixed the mistakes that I made.
Okay. Let's take a look. Give me your notebook. Who's going to catch the right mistake here? If we can see it, of course. Looks like we are disconnected, but okay, I've spotted your mistake. We can talk after the class. Sorry, it didn't work. I was gonna show you everyone and figure out the mistake, but alright, any questions on this question? Problem? Did everybody get this 100%? I don't think so. You're hiding it. I mean, you missed this part, but you're not telling me. Which part are you lost? Okay, let's test it then, how well you understood. Let me first substitute my answer. What was my answer? 5c plus 12, 5c 7. I want you to try another one. Let's see if you can do the solution on a separate page and turn it in. So this is a quiz. Let's see if you really got it. What percentage of the class got it? and cover your notes.